So good afternoon, everybody, and thank you for being with us today. I'm Sara Pittonet, Senior Project Manager at Trust IT and the coordinator of the Blue-Cloud project. I'm very happy to welcome you today to this webinar, which is a satellite event of the 6th Ocean Decade Laboratory on the outcome An Accessible Ocean. And the event is hosted by the German Federal Ministry of Education and Research in partnership with the Intergovernmental Oceanographic Commission of UNESCO. So today in this Ocean Decade Satellite activity, we will present you 3 practical pilot initiatives that are developing open access marine data knowledge-based solutions that are exactly what is needed for a transparent decision making. To do so, they are leveraging on the Blue-Cloud platform, which is federating data and services from existing European data infrastructures and infrastructures into a virtual research environment to enable researchers to perform, combine, reuse, access, and find data across disciplines and countries. So Blue-Cloud is the Future of the Seas and Oceans flagship initiative of the European Union Horizon 2020 program. And it is the thematic open science cloud for the marine domain. As I mentioned, the aim is to promote the sharing of data, processes, and research findings, and we do so by a collaborative web-based environment that gives access to an unprecedented wealth of marine data resources and interoperable services and products. Blue-Cloud is federating European horizontal infrastructure such as EUDAT, Science, Copernicus, DIAS, or Wikio, with long-term marine data infrastructures to create a unique framework, a trusted environment that is accessible by scientists that can access the data, the ocean data, marine data, tools, services to perform the research. And that's exactly what the 3 speakers of today will introduce you. So the 3 pilots that you'll meet were awarded at the Blue-Cloud Hackathon that took place in February this year, and that brought together almost 150 participants from a diverse community of marine science practitioners, computer scientists, innovators to test the Blue-Cloud web-based solutions and ecosystems of services to address selected ocean challenges. With over 30 teams that participated in the hackathon, Delphine, Ines, and Bryan, that you'll meet later on with their teams, were awarded as best ideas. And we're very proud to see that the pilot applications are entering a second phase, evolving into services that might be uptaken by other stakeholders in the marine research field. So today you learn about See Clearly, a pilot service that aims at providing the locations and conditions for safer pollutant-free fish to be farmed in aquaculture cages. You learned about AqADAPT, which is a pilot tool that helps policymakers and aquaculture farmers ascertain future conditions relevant to aquaculture at a location of interest via a modular geospatial web application. And you learn about the wildlife tracker for oceans that aims at supporting the protection of marine megafauna based on real-time geospatial technologies. Altogether, these pilot services address at least 3 of the Sustainable Development Goals of the United Nations, so namely number 2, zero hunger, number 13, climate action, and number 14, life below water. With that, I leave the floor to our speakers, and I invite you all to join the Blue-Cloud and to try it out the services there. We like to say that Blue-Cloud is your open science platform for collaborative marine research. So thank you very much. I leave the floor to our speakers, and I remind you that you can use the question and answer panel in the Zoom facility to ask any questions to Blue-Cloud team or to our speakers today. So I think the floor now is to Delphine, I think, is the first.
I'm just going to share my screen. Okay, you should see it as a full screen now, right?
Yes.
Perfect. Well, thank you, Sara, for that introduction, because that's at least, it sets the scene for, you know, what we actually did a couple of months ago with the hackathon. And now I can go into a little bit more detail about the idea that we put forward. So the idea that we proposed is called See Clearly, and it is basically a visualization tool in order to do an environmental impact assessment on the ocean plastic in the Mediterranean and see the impacts of the plastic pollution on and by the aquaculture farms. And so you'll see that there was a big team of us and from different universities around the globe. Most of us were from Utrecht University, which is here in the Netherlands. And I am a postdoctoral researcher at Utrecht University. And I'll show you an image with all of the team members at the end. So to start with, I'm actually just going to show you one of the deliverables of the hackathon. And there were 3 different things that we had to produce during the 2 days. And one of them was a video to explain our idea. And so this will give you a good idea of what we proposed.
Are you an aquaculture manager looking for a pollution-free location for your next farm? Or a decision maker assessing if aquaculture farms can pollute marine protected areas? Or are you simply looking for clean and safe fish to eat? Then See Clearly is a tool that can answer all of your questions. The particle trackers used the Blue-Cloud to develop simulations and a web-based visualization to track pollutants in the ocean. You simply open the web page, click on the location of an aquaculture farm from the Blue-Cloud database, and trajectories of harmful pollutants appear, which have traveled to or from this farm. So how did we produce these simulations? In a Jupyter notebook on the Blue-Cloud, we combined an open access Lagrangian framework called ocean particles with ocean currents from seamounts and released virtual particles of one pollutant, microplastic, from one origin, the coasts or the aquaculture farms. With an extra €25,000, we will integrate other Blue-Cloud data, including all pollutants and aquaculture farms, marine protected areas, and even winds and waves to simulate storms. With our probability analysis, we will generate a public, fair, compliant contamination risk map of the Mediterranean to share with stakeholders and educate the general public. Everyone has the same goal when it comes to aquaculture farming. Producers, consumers, and decision makers want to ensure safe, clean, marine-based foods. Let's See Clearly provide you the pollutant tracking you need.
Okay, so just to go through a little bit of, you know, to summarize basically our idea, we wanted to come up with a what-if scenario that was focused on aquaculture farming, and we wanted to look at developing an environmental impact assessment tool to determine which locations had the lowest probability of plastic pollution reaching aquaculture cages, and also due to the wear and tear of the cages themselves and the release of particles into the ocean, whether these particles can actually reach marine protected areas, for example. And so the stakeholders or the end users of this tool would be aquaculture farm project managers themselves, so those who are actually looking at expanding and placing some cages in different locations, or even moving the current cages that they have into areas that have a lower risk of being in the pathways of plastic pollution. Then decision makers who do the marine spatial planning, for example, and also accreditation bodies, so those who decide whether a new business can be set up, for example. And then the general public, so this can be used for ocean literacy and to explain, you know, the risks and where there are potentially areas that could have more risks or less risks. And so this is of interest to the general public, both when they use the environment, for example. So, you know, if they're on the beach and they litter, basically, if this can reach an aquaculture farm, or even if it can reach from other ways, and this is the food that they are actually buying for consumption. So the Blue-Cloud facilitated this entire process thanks to the fact that, well, Sara already explained a little bit about the Blue-Cloud and how the different tools that they provide and the data. And so we used the Copernicus Marine Services for the advective fields and also eModNet for the aquaculture cage locations. So this was all available on the platform provided by the Blue-Cloud. And then we combined this with the, so our expertise is in Lagrangian particle tracking. So this is where you really trace a particle that's moving around the ocean and it can follow the different currents. And this is all open access. So this is this can really be used by anyone who would like to look for it. And I'm going to provide the link for the open access GitHub page afterwards. And all of this was combined. And then one of our team members who is at Florida State University, Onmo, he is in charge of this particle visualization tool that is available on the web. And I'm going to show you in a little bit what it looks like. But so this is basically where you can really see the particles moving on a very simple, easy to use software. And so moving from, the actual hackathon and the fact that we then had 6 months in order to further develop the idea, we decided, well, we're going to take this, the prize money from the hackathon, and we're going to further develop the idea by looking at all the aquaculture farms in the Mediterranean. So during the hackathon, we used one aquaculture farm in one location as a kind of pilot project, and now we would expand to the whole Mediterranean. We're also going to be doing a hacking trip in France next month. And so we're going to do some interviews with some of the stakeholders that could be interested. This is also linking with the European Commission mission Starfish. They have an event in France, and we have been invited to present and to actually interact with the stakeholders there. And then we're going to organize an outreach event. And yeah, as I mentioned, we would like to further develop not just the model, but also the tool that you're going to see, so the visualization tool. And yeah, here you can see the name of the team member who was in charge of that. And in a second, I'm going to go to the website. And further, we would like to actually take this beyond agriculture farms and plastic pollution, and we would like to convert this into a consultancy, so into a startup, and look at more pollutants than just plastic. So look at all the ocean pollutants that we can track and we can model. Then scale it up, so looking not just at the Mediterranean, but looking from local to global scales. And finally, having a service that is customizable for different clients, so different businesses that would like to use this service. And just to end off before I go to the website, I would like to thank all of the team members, because we were made up of early career ocean professionals. So this was really kind of a bottom-up type of project. And as I mentioned, there are everything is open access, so you can really find the you can click on these links, or I can share them in the chat, so that you can see both the particle viz and the ocean parcels. So this is the Lagrangian particle tracking and the visualization tool. And if you would like to contact us, here are our contact details. And finally, I would also like to really thank the Blue-Cloud, because without this, we wouldn't have had the time to, really think up of an innovative, applicable idea that, that we could really do this link between our research and innovation. So now I'm going to move over to the actual tool itself. So I'm just going to stop sharing and then reshare. So just 1 second. Okay. So hopefully you can see my screen now again. And so this is what you just saw yeah, so I'm going to zoom in, for example, to the location that we had chosen. So here off the coast of Italy, and you can decide to do either backward or forward tracking. And so here you'll see the particles being released and moving with the currents. So you can change the color of the particles. You can change it from a dot to a line. You can make these smaller and bigger. And you can also increase the tail, for example, of these trajectories or reduce them so that you just see dots. So these are some of the functionalities that are currently being worked on by Onmo. And yeah, I mean, if I show you the forward, it might take a while to load. So maybe I can leave it there. But if you want to play around with it, then please do. You can, I can share the link in the chat and you can play around. But yes, that's all I wanted to share with you today. Thanks for listening.
Many thanks, Delphine, and no, thank you, I mean, for pulling out such an interesting tool with the resources available. That's the purpose of Blue-Cloud. So best of luck, and then let's go to the second speaker of today, Ines Haberle.
Hello, let me share my screen. Just a second. Sorry. Can you see the screen? Okay.
Yes.
Great. So hi to all the participants. And first of all, I'd like to thank the organizers for the opportunity to present at this workshop. And of course, a big thank you to Blue-Cloud for the possibility to make our tool possible and to make our idea to realization. And we are 10 of us in the team. We are a team of scientists working on two different institutes in Zagreb and Osijek in Croatia. And we are usually collaborating on different projects and also some of them working in aquaculture. And together we came together for the Blue-Cloud Hackathon, which was a really great experience. So just in short, of course, aquaculture is a key for sustainable development, and it's also a part of big initiatives such as UN Sustainable Development Goals, EU Mission Starfish, Farm to Fork Strategy. And but stakeholders related to aquaculture are faced with a range of uncertainties that might slow down the investment into aquaculture, and understanding how consequences of climate change especially play a crucial role to increase the confidence of the policymakers and increase the confidence of the investors to speed up the growth of aquaculture. Some of the main stakeholders that we were focusing on are aquaculture farmers, aquaculture investors, and policymakers. And some of the questions they are arising are, how much do I need to invest to make my aquaculture profitable? Which fish should I farm? How fast will my fish grow? Will the disease in certain areas or aquacultures be a problem? And how can policymakers develop the policies that will help develop aquaculture in a sustainable way? And everything what is happening now is happening under the roof of climate change. So actually what we need to understand is what will the future bring. So here we come with our idea. So what is perfect? We wanted to contribute to untangling some of these questions. And the idea that we developed is a user-friendly but science-driven platform that would be able to forecast the effects of climate change and kind of translate make the link between the research and development and the industry itself. And we want to translate the science-based results into some informative performance factors that can be easily be understandable by aquaculture stakeholders. And the three performance factors that we focus on are a food conversion ratio. So how much do I need to invest into food to gain the fish to the certain size? what is the time to market? So how long will I need to grow my fish to get to the market size? And also the risk of the disease. So will my aquaculture be on higher or lower risk of disease? So the platform itself combines a range of different open data, which thanks to the Blue-Cloud, we managed to gain from the different platforms, and also then provide back to the Blue-Cloud that is now available. So we collected the temperatures, which from Copernicus, we downloaded the grid data from your European Environmental Agency, fish farm locations, and the locations of the MPA, which were downloaded from different platforms, including Blue-Cloud, and some local data from Ministry of Agriculture in Croatia. And also to run the species model, we download the species parameters. All of this data, so in total, it was 2 terabytes of the raw data, which we then stripped down and used managed to strip down to 10 gigabytes. And now all the data is put back on the Blue-Cloud, and now it's available. So I'm actually really happy that now some of the local Croatian data is available on the Blue-Cloud, which was not available before. So the science behind our platform, it's actually our 2 main models. So first is the dynamic energy model, which is actually the model how the energy flows through fish and how will the energy from the environment impact the growth of the fish. Usually what you get in research is these graphs that usually stakeholders either they get tired of it or it's sometimes hard to understand. So what we did, we run the model and then translate this to these performance factors. So from dynamic energy budget model, we get time to market and a food conversion ratio. And the second model that we use is the Vibrio growth model. So it's actually how the bacteria will grow in a specific environment. And we convert this data into index that will show how long is the exposure during the year to bacteria. So the functionality of the platform itself is divided into 4 main sections. So first we have the user input, where the user selects the location, selects the species they're interested in, and selects the RCP scenario, so the climate change scenario they want the prediction for. The second is that the platform takes the data, so it takes the daily temperatures for the forecast, so hindcast and forecast, so it takes from 2010 to 2052, and also the species parameters to make to run the species model. And then the models itself are run. So the DAB model for the fish growth and the Vibrio model to obtain the amount of bacteria. And everything is integrated through Jupyter Hub and hosted on the Blue-Cloud. So this is just the slide to make it on one. It's not so friendly because it's a lot of letters. So what I wanted to do is like show you how it really works. So now I'm going to show you just through a few slides how actually it works. So currently this is our platform that it's available through the Blue-Cloud itself. So currently we're focused only on the Mediterranean, but the platform itself can be extended to the whole world in the future. So what you can do, you can stroll through the map and you can see the 2 different types of blue. So you have this blue parts markers that are actually indicating the existing aquaculture sites. And if the information on the aquaculture sites exists, which fish they are growing, you can see the species that are growing. For example, in Croatia, we have this 2 main species, Parus aurata and Centrarchus labrax. And also the EEA grid gives us opportunity to select the areas that are still areas that you might be interested, but aquaculture doesn't exist. So this is mostly for someone who wants to plan aquaculture in some other site and is interested how the aquaculture will perform in that site. So you can select any of those squares as well. So next, what you select after you selected the location, you can choose from the range of the species. Currently, we have the main species that are grown in the Mediterranean, and also we included some of the ones that were explored. They're still not grown, but they show the potential to be grown in the future. So you can explore these two. Then you can select the scenario. So currently we have two RCP scenarios, so 4.5 and 8.5. And then you just click simulate and you can trace your progress. And in the end, you end up with three performance factors that you can observe. So what you can see here is actually feed conversion. What you get is the changes of three performance factors are in relation to reference year. So if you see that something is in the red, it means that according to the reference year, it will get worse. And if it's in the green, so it's lower, it will get better for that performance factor. So we can see if the this is the for RCP scenario 8.5, and we can change the scenario and make another simulation, and we can see that the results change. So for example, for the 8.5 scenario, the vibrosis risk was much higher than the 4.5, but the time to market was lower because in the higher temperature, the fish grows faster. So for the further development, we actually are planning to expand the platform for additional user inputs. So if somebody has the local information about the local temperatures, they would be able to put the local information. It would be possible. It will be possible to change the reference year. So currently it's set to 2022. But it would be, and also it would be possible to select the time frame for which one wants the simulation, because currently we run the simulation for the until 5052. We want to also extend the resolution, so make more depths, because currently we only use the surface temperature, but we can extend it with more depth. And also we are working on improving the Vibrio model, because currently it's the basic model that is used, and it's only taking into account the temperature itself. But we know that the bacteria is not only impacted by the temperature, and we want to be able to make a model that can also take into account, for example, eutrophication, that or amount of organic matter that we know impacts the growth of the bacteria and can also induce higher pathogen impacts on aquaculture. And of course, the code is currently open on the Blue-Cloud, and the application is limited and its testing phase, but and results are of course not totally reliable for informing aquaculturists, but it's there for everybody to test the platform. We are open to any user feedbacks and thoughts what can be added, or it can be added by you as well, because it's open on the Blue-Cloud. We are also planning to collaborate with stakeholders and aquacultures. And with this, I want to thank you. You have my email here, so if you have any questions. And once again, a lot of thanks to Blue-Cloud and UN for organizing this event and for applying us to be able to participate. So thank you.
Many thanks, Ines. Did you say that you are already testing this with farmers, or is this a second for a second phase?
We are now talking, because we are on other projects, we are collaborating with them. So we are actually planning to put that on test and get their feedback, what they think should be added. Or so yes, we are. This is still not going, but it's gonna be in a month or two, because it was when we had our session, what was it called? Yeah, when we had the brainstorming sessions for the startup companies, we had this idea of making a testing phase, and it will also happen during the event that we will be organizing.
That's great. Thanks, Ines. So unless there is any question precisely for Ines, we can move on to Bryan. He's the last speaker for today.
You're muted, Bryan.
Hello. Yes, now I am on. Well, thank you very much. Thank you very much for this space. I'm glad to give this presentation. I would like to introduce what is it, the Wildlife Tracker for Oceans. So we are 4 team members. Me, that I am actually geospatial developer. I'm creating the platform. Sophia Green, who is a marine biologist. Actually, she's working in Galapagos Islands and she's working with conservation of whale sharks. Chan, who is actually organizing all the work, and I would say she's kind of a Scrum Master part of the team, and Ederson, who is the person in charge of creating digital products for sharing, for awareness of people. So, well, first of all, what is the Wildlife Tracker for Oceans? So it is simply a cloud share framework that is dedicated to real-time movement analysis of wildlife tracking datasets. It has a connection to Argus satellite, so you can actually take a look at the movements of your marine wildlife in the same way you're looking here. This is just a screenshot of the platform. You can access by secure credentials, so all your data is going to be safe, and we never store these datasets. And this is just the first look of you as a user. Well, then, what is it able to? It is able to retrieve ocean monitoring data products from open services, for example, Blue-Cloud. First of all, thanks for Blue-Cloud, we have the chance to test with phytoplankton products, and you're able actually to choose the date where you want to overlap this movement data. So, well, I will explain you why this is useful. Well, one of the main things we have done during these last months is the implementation on Galapagos Islands, thanks to the Galapagos We Share project. So you can see in this picture, she's Sophie, she's part of the team, and she works tagging whale sharks in the Galapagos Islands. So it's actually quite inspiring. After she puts the tags on the whale sharks, we connect the wildlife tracker to Argus, and we start doing the visualizations. So then why are we doing this? So this is just an example from the hackathon. What we did is to understand how the concentration of phytoplankton changed during the year. And we realized that when the concentration of phytoplankton goes to specific places, the migration of marine wildlife is also going to the same places. So we noticed that the marine spatial planning has some gaps in the delimitation of marine protected areas based on these meaningful spots. So what we want is to support data-driven decisions for marine spatial planning, specifically based on marine megafauna habitat. So specifically to whom we are creating this product is to marine scientists and institutions dedicated to marine conservation and movement ecology who are willing to support marine spatial planning. So I'll show you here. This is just a flyer because we are going to give some events probably next month and also in July related to Blue-Cloud and how you can use the products of Blue-Cloud and Wildlife Tracker. So please, I recommend you to stay tuned in order Twitter account, so you can follow what it is going on with the development of the wildlife tracker. We have some products coming in the next months. Just adding the visualization, the movement of wildlife with ecogeographical changes of the ocean, and creating products that can be used for statistical modeling. I would like to show you just a quick video about what we have done for the implementation. So, well, that's it. So please try to visit us in our website. If you have more questions, you can also contact our website. We have a gallery. Also, we have an online demo and more descriptions about the Cloud Share framework. So I would say thank you, Blue-Cloud, and thank you everybody for listening.
Thank you very much, Bryan. Yes, just ask if you can also share the link to the YouTube video so that we can pick it up and watch it again. Okay. So thank you very much. Not sure if there are any questions from the people in the audience. Otherwise, I think I really wish you all best of luck with your applications. We hope to continue seeing them and working with you. And we also invite you to give feedback to the Blue-Cloud team. That's very important. Thanks, Bryan. Okay, I think we've done with that. So we'll leave you back to the main conference and the other events. Thank you again, and let's keep in touch. Thank you all. Have a nice afternoon.
Thank you very much.
Bye.
Bye.